Hey, Wire Monkeys, welcome to another episode of Let's Talk Cabling. This episode, we're talking basic electricity. Welcome to the show where we tackle the tough questions submitted by apprentices, installers, technicians, project managers, estimators, even customers. We are connecting at the human level so that we can connect the world. If you're watching this show on YouTube, would you mind hitting the subscribe button and that bell button to be notified when new content is being produced? If you're listening to us on one of the audio podcast platforms, would you mind giving us a 5-star rating? Those simple little steps helps us take on the algorithm so we can educate, encourage, and enrich the lives of people in the ICT industry. Wednesday nights, 6 p.m. Eastern Standard Time. What are you doing? You know I do a live stream where you get to ask your favorite RCDD, and you know that's me, your questions on installation, certification, design, project management. I even do career path questions. But I can hear you now. But Chuck, I'm driving my truck at Wednesday nights at 6 p.m. I don't want to get into an accident. I record them, and you can watch them at your convenience. And finally, while this show is free and will always remain free, if you find value in this content, will you click on that QR code right there? You can become a Patreon member. You can go to the webpage, buy stuff through the Amazon link, or we're also looking for corporate sponsorship as well. You know, I've been an ICT technician for 40 plus years. Sometimes I think about that and I go, wow, I forget how old I am until I'm trimming up my mustache and I see all the gray in my mustache. It's like, it didn't used to be that way. I should probably throw up a picture of me like when I'm in my 20s. And I realized that one electrician, there's always that electrician versus low voltage, which is better, right? Well, there's one area where electricians are always almost better than us. And that's when you start talking about volts, current, watts. Ask a low voltage guy to explain that kind of stuff to you. Yeah, good luck with that. Unless you happen to find one who's also an electrician. So I'm dedicating today's show into what exactly are these things. And so I got to thinking, who would be the best person to bring this on the show to discuss? And of course, my dogs are barking. And of course, that had to be my good friends from the JATC in Las Vegas right after the Bixie conference. Dang it, I wish I could have gone there. Matt Apfel and Brandon Duffy. Hello, gentlemen. Welcome to the show.
Morning. Good morning, Chuck. How you doing today?
I'm doing fantastic. Anytime I get to talk with my buddies, it's a good day.
Yes,
so
sir.
let's go ahead and do the introductions. So for the three people who listen to my show, and since two of them are actually on the show, so the one person who watches my show,
I'm on.
Let's do an introduction. Who are you guys, and why should we listen to you? We'll start off with you, Brandon.
Well, my name is Brandon Duffy. I'm the recently minted curriculum coordinator for the JTC in Southern Nevada. I'm a somewhat forcibly retired mathematician. I taught public, private college mathematics mainly, and my scope over here is teaching a broad array of curriculum classes with a heavy emphasis on mathematical computation.
Very cool. Matt?
Well, my name is Matthew Apfel. I'm one of the assistant training directors here at the Electrical JATC of Southern Nevada. I'm a senior technician. I've been here at the JATC for about 15 years now, and full-time as an assistant director for 3 years. But being a senior technician, a Big C RCDD, a technician, as well as a certified trainer, we deal with a lot of different aspects of the limited energy information communications technology industry. And one of those things that we see more and more of these days is power delivery. So that's what I'm here to talk to you about.
Right. And you know, one of the reasons I really want to get into this stuff is for low voltage installers. For many, many years, it's okay to have a cursory knowledge of volts and amps and current and watts, you know, but now with power over Ethernet and fault managed power systems and all that other stuff being rolled into our job description, it's even more critical that we understand this stuff. So let's kick this off with volts, right? Can you explain what is volts in its simplest terms, and how can you compare that to something familiar to the techs in their everyday life?
So the analogy that you typically see in the classroom and a lot of T-shirts that you buy off the internet is you got the three guys, you got one trying to push another through the tube, and you got another with a rope cinched around the tube. And the analogy for the volts is it's pressure. And pressure is a somewhat unitless quantity until you decide what trade you're applied to. If you're a plumber, you know it's going to be pressure between two opposite ends and some kind of fighter in between. With us, it's the quantity that's trying to push electrons, for lack of a simpler phrase. It's just pressure. And one of the things that tied me up in my apprenticeship was it requires two locations to be able to talk about it. You need to talk about a voltage from point A to point B. You can't just look at an instantaneous point. It's a difference. It needs two quantities. Voltage is it's an operator. It's not a specific value.
Matt, how does voltage affect the performance of low voltage cables? And what is and can you settle the difference? I mean, settle the argument of what is low voltage, what is high voltage? Because you hear that a lot.
And that's an excellent question because it depends on who you're talking to. Low voltage, if you're talking to a lineman, will typically be anything below a certain thousands of volts. If you're talking to an electrician or a journeyman wireman, a low voltage might be anything less than 120 volts. But if you're talking to a technician, low voltage would typically be anything below 24 to 48 volts. So it just, who's your audience? And the reason why that's important these days is that because the technology, the industry is changing so much, we need to really quantify and really nail that down. And the difference is these days is that with cabling, when you're talking about voltage, now we're starting to see a mix of cabling types. We're starting to see communications cable with a certain voltage rating on its jacket being mixed in with power conductors that might have a different voltage rating on the jacket. So depending on, no matter who you're talking to, you need to be able to identify what voltage is, what the cable type is, and make sure that if you don't have an honest understanding of what it is, that you're not committing code infractions or other violations that might get you or your contractor in trouble.
Hey there, business owners and tech enthusiasts. Are you tired of dealing with outdated technology and unreliable IT support? Introducing Better Days Technology, Rhode Island's premier IT solution provider. Whether you need secure network setups, top-notch cybersecurity, or seamless software integrations, Better Days Technology has got you covered. Don't let tech troubles hold you back. Visit betterdaystechnology.com or call 401-440-5483 today. One call to us and you'll be having better days. Now, let's get back to the podcast.
So how does voltage affect the performance of a low voltage system, though?
Okay, so if you were talking about a PoE system, okay, where PoE cabling is typically referred to as watts. Well, we're going to talk about watts here in a second, but watts in power has an applied voltage to it. That voltage is what is necessary along with the wattage in order for our appliance and what the end product in order for it to work. We can also see voltage in cabling in the audio systems. You see a lot of audio systems that might be 70 or 100 volt audio systems where if the proper voltage isn't applied through the cabling into the speaker, then you're just not going to work properly. And the installation and the understanding and how it's installed and how many speakers, where it's applied on the amp, all those things are super necessary these days in order for a quality install. So having the right voltage, having the right cable is very important.
And again, voltage being the difference in pressure of an electrical nature, so to speak. You put a little rotary garden water sprinkler out there. How much of the garden do you want to hit? You know, do you want to apply 15 volts and get 200 gallons of water out there over 3 hours, or do you want to hit it with 100 volts or 120 for this matter, and actually hit the entire garden in 5 minutes?
Oh, I got the perfect analogy for this. So if you follow me on my journey of life, you know that I'm a homesteader. I call myself a farmer, but I'm really a homesteader. My wife has a butterfly garden. So anything on the property that we grow has to either attract bees, feed us, or feed the livestock on the property, right? We don't grow stuff just because it's pretty. So my wife's got a butterfly garden where it brings her joy. So she finally talked me into doing it. So we put a butterfly garden out there. It's not that big. It's maybe, I don't know, 20 feet by 20 feet, and it's got lots of pretty flowers in it. And so we went out and bought these waterers. They're made out of copper tubing. They come up and they have two circles. And you hook the hose at the bottom. And what happens is those circles spin and the water comes out in like a globe fashion, right? So we had one in our butterfly garden. Worked fine. And then she said, well, it's not getting water over in this other area. So we went and bought a short piece of hose, attached it to that, put in the second one. Guess what? The second one wouldn't spin because there wasn't enough pressure. Volt analogy? Yes or no?
Absolutely.
Perfect.
Yes. Feel free to use that in your class. Just make sure you give me credit. Now, let's shift the conversation to amps. What are amps and how do they relate to the movement of electricity?
So amps being in units of coulombs, amps are essentially the speed of, I guess you would say it's the electrons moving, but more in terms of more practicality, we use the forces that those moving electrons create. That ties into voltage too. But amperage is it's the big problem when it comes to the rating of the conductor. What you're gonna use to send amp from point A to B. That's our heat factor. That's what's gonna start causing problems. And we'll talk about wattage here in a minute, but it's the amps that you rate the circumference of the pipe that you're sending the water to from point A to point B.
So if I had gone with smaller hoses on my butterfly garden waters, they might have worked.
Absolutely.
Well, actually, that's kind of what we did, but that's beside the point. That's beside the point. Now, when you started your explanation off, you used a term that I never heard before, but gosh, my memory's already forgot what it was. If I can think, I'll come back to it. Settle this argument for me, okay? I'm not an electrician. I am just a low knuckle dragging, low voltage cable guy who doesn't know anything.
I know.
Right? So, so I've seen people, not people, but various sources of information when they talk about electricity. Some sources say the electrons go from one end of the cable to the other end of the cable. Other sources say they just go back and forth. Which is it?
So right there is the analogy between AC and DC. And I mean, despite direction, they're really not different. And if I'm playing Mortal Kombat in America and my teammates over in Vietnam, am I sending an electron from here to Vietnam so that the data can be transferred? And the answer is no, absolutely not. Without having to talk about induction or transfer of power, what we are caring about is the transfer of the forces that are created by the electrons fighting each other, essentially. We're moving voltages around, and that is caused by the change of amperage, but it's resulting forces and properties that creates that we're interested in.
Gotcha. Matt, when working with low voltage, what is the practical significance of amps? And how does understanding amps help us from causing problems or mistakes in the field?
Well, there's a lot of different appliances and things that we're plugging in and hooking up these days. And those appliances, and I'll use something like a camera, for instance. Okay, if the camera has a DC power supply that's powering it, you need to make sure that it has the right voltage, but also the correct amperage. Because if it doesn't have the proper amperage, let's say the amperage is too low, it's just not going to work. If the amperage is too high, it might work for a second or two, but then it's going to overpower itself and you might let the smoke out. So a too high or improper amperage can cause the heating of the conductor. It can cause problems. And the conductors, or the copper, the aluminum conductors themselves, are rated for the amperage that you're going to be applying across them. And as Brandon said, it's anytime you have the transference of energy with voltage and amperage, then it creates heat. And that heat can cause a problem. And that's one of the problems that we see today in the industry a lot is people not applying the proper power via whether it be AC or DC, having too many cables bundled together, appliances too close together, stacked in racks, and then you have an overheating problem and you have a breakdown, you have a thermal breakdown, and you let the smoke out. So that's a huge problem with the delivery of current and power and amperage in the industry today.
Let me apply this to a story that I heard. This did not happen to me. Okay, this is a story.
Of course not.
So a long time ago, a friend of mine had a ModTap SLT3 tester. Now, for those who don't know what that is, it's just a simple continuity tester. It had 4 lights on it. You'd plug it into the cable. You had a remote you put on the other side, and it would light up pair 1, pair 2, pair 3, pair 4, and they better be all green. If one of them turned red, you had a reversal, right? And it said on the instructions, not that anybody read the instructions, don't plug into an active circuit.
What'd you do?
Let's just say that somebody might have plugged it into an active circuit, and the LED light started smoking and it burnt it out. Was that because of amps? Too much amps?
Yeah, I'd say so. When we start talking about power here, we're going to learn that voltage and amperage have a pretty significant relationship with each other, and that voltage, when you apply more voltage, it actually affects the current. So, and it affects what you're plugging it into. So, you probably had too many amps, but you also probably had too many volts, which then therefore affected you as well.
But it's low voltage. It's low voltage, though.
Yeah. Well, it used to be that if you were a telco technician, all you cared about was your ring voltage. All you cared about whether or not you had dial tone and whether or not the circuit was ringing and you had loop back, and then hopefully your hand wasn't on the 66 board when you were punching things down because you got bit.
Yeah. For those who don't know what ring voltage is, in the old days before wireless, when everybody had landlines, when they had to send voltage down the cable to ring the bell in the phone. That's where the term ring voltage comes from. And I remember we did a project at JW Marriott, downtown Washington, D.C. We had to tone out every single phone line in that building, all the rooms, back of house stuff. And it was so funny because the guys, they would take their probe, which I have one on my desk. Here we go. They would take their probe. Now, back then we had metal tips, and they would put it on the thing and they'd go down until they heard the beep, right? Well, they realized that was kind of slow. So what they do? They took the probe, turned around in the back of their hand, licked their finger, and would just go down the block, 66 blocks, real quick with them. And the first time they hit ring voltage was really hilarious because they went, wow. By the end of the project, they were just going, yep, ring voltage. Yep. Right? Yeah. It'll wake you up. That's for sure. It'll kill you, but it'll wake you up.
It'll light you.
It's better than a cup of coffee. It doesn't taste as good, but it'll wake you up.
Arguable.
Now let's shift the conversation to current. Okay, Brandon, can you break down the concept of current and in a way that would make sense to even us low voltage people?
So, quantity aside, current is just the amount of electron flow from point A to point B. It's the water in the pipe. And when water moves in the electrician's pipe, again, we create the heat.
Matt, you get to explain current and how it affects the low voltage installed. Remember, low voltage is everything from voice data to fire alarm to DAS to everything.
Yeah, and that current, whether you're talking about the transfer of electrons themselves, it's that is the power, that is the water, that is the juice, that is what's making things work. So once again, today's electronics and today's appliances that we're installing in the field are very, very sensitive. They are exact. The tolerances in which that these items are manufactured are not very yielding at all. And back to the whole idea of too much or too little when it comes to current, that's the make or break. And that is what's very important about our installation these days, because if you have too much resistance because your cable is junk or you have your terminations are improper, then that's going to affect your current. You're not going to have enough power delivered to your product that you're installing, and then it's just not going to work. So the current, the electrons, what kind of water you're actually getting, that's going to make or break your situation.
And in terms of, like you said, the water that we're moving, low voltage may depend. The definition of low voltage may depend on what trade's doing it. if the wiremen are running right next to the techs, our water tends to talk to each other. That's why we have a separation. The last install I was doing at a convention center, the typical separation between power and data would be anywhere from 10 inches to 12 inches. Our water talks.
Yeah, it does. Let's take a side step for a second. Let's talk about safety for just a brief second or two, right? You hear all the time, take steps to protect yourself from being injured from working with electricity, even low voltage stuff. And some people will tell you it's not volts, it's the amps. It's not amps, it's the volts. Which is it that causes problem and hurts people?
So, yeah. I have the distinction of being popped by 880 DC, changing a fuse, as a unspecified year apprentice without proper supervision in a local that shall not be named. And I'll tell you, 880 volts DC will knock you unconscious. You'll wake up 10 feet away from where you were previously with your journeyman running over to you asking if you're live. And that's without a load. I'm alive today because there was no load on that. Now, at the same time, I've had the privilege of holding on to a 120 cord, working with Dad at home with a load on it, not being able to let go of it, and just watching it kill me. So, long story short, it's the wattage created within the body that's going to kill you. It's going to be the wattage that kills you.
Yeah. So
that's actually a perfect segue, because the next thing I want to talk about was watts.
Hold that thought. Let's listen to a short message from our sponsor. Don't go anywhere. Bessemer Industries is your trusted partner in cutting-edge telecommunications and security solutions in Central California. From structured cabling and fiber optics to comprehensive telecom and surveillance systems, we've got you covered. Enhance your business with seamless connectivity and top-notch security. Our licensed and insured team ensures that you get the best service tailored to your needs. Why choose Bessemer Industries? Expertly crafted solutions, reliable and secure installations, licensed and insured professionals. Don't wait. Connect with us today and elevate your business to new heights. Bessemer Industries, connecting and securing Central California's businesses one wire at a time. Visit us at www.bessemerindustries.com or call 559-314-7050. Bessemer Industries, your link to seamless connectivity. Now, let's get back to the show.
I didn't even know that. As we were talking, you were talking about volts and amperage. It hit me that, in the Bixby thing, it tells you, well, if the heart stops beating at 250 milliamps, and I've heard other people say, no, it's not the voltage, it's the amps, and blah, 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 blah. So what I'm hearing from you guys is it could be both.
It is both. And I'll kind of put it simply, since we're going to kind of lead up into power and watts next, is that here's an item. Okay, it's not very large, it's not very heavy. It has a certain mass. So we'll say that this is a certain load or this is a certain amperage. If it's not moving very fast, it's not going to hurt. Okay. If I don't have too much pressure, it's not going to hurt. Now, if I were to stand back and to throw this at you, it's going to hurt.
Verified.
So that's kind of the analogy of which is it? Is it the volts or the amps that hurts? Well, if applied together properly, it hurts.
So I had an amazing example related to me years back. The human body is absolutely astounding in its complexity, and we have tens, if not hundreds of thousands of volts within our system just moving things around, and electrons shooting back and forth all day. And we've got current moving through our body through neurons, and they're all traveling at the same point. There's enough amperage in there to kill you several times over, but it's not until with those powers combined in the perfect storm that you're getting enough wattage to slam you through the wall, and that exists in the human body.
Yeah, and the human body is the majority of it's water, and there's a lot of salt in our body, and both of the salt water,
Mm-hmm.
I mean, it's conductive. Don't ask me how I know that. So like I said, that was a perfect lead into watts, and that was done totally unintentionally. But it just worked, right? Watts. Okay, Brandon, you hear a lot about watts. What exactly is a watt? And how do they bring volts and amperage together?
Okay, so mathematics aside, watts are by definition resistive voltage times resistive current. It is a instantaneous value, so there's a lot of confusion when it comes to my power bill. What's a watt hour? A watt is a instantaneous moment of work. Well, what is that? You can take a picture of a weightlifter lifting much more than I can, take a picture of it, and it looks pretty easy. I can do that. Well, how long is he holding on to that weight? And that's a watt hour. It's work. That's why we're billed in terms of kWs or kWh, kilowatt hours. One of these days, I'd like to call the electric company and say, I only use about 235 watts. What's the problem?
Matt, bring it together for us. How does watts affect low voltage? Especially, let's talk about choosing the right tools and also PoE.
Yeah, watts is the rage these days. You're starting to see more and more things that are expressed in watts because as call it low voltage consumer grade appliances, cameras, access control items, PCs, monitors, all these things that people just used to plug in and just didn't even care. But the more that these things are actually powered via limited energy, either distributed DC or PoE, power over Ethernet, they have a watt value. They have a certain amount of work that is required by the circuit in order to make it work. And in PoE, 20 years ago, when this technology first started coming out, 15 watts was common. Then it turned into 30 watts. Then it turned into 60 watts. Then it turned into 90 watts. And now we're seeing more than 90 watts. We're starting to see 100 watts. Well, what does that mean? Well, it just means that more and more things are able to work off of power over Ethernet. More and more technicians in the field today that are installing cable and infrastructure for these systems, their work, their end-of-line product is dependent upon the wattage and the correct installation of these things. So in the industry today, an average technician, the expectations of him having to understand the infrastructure, understanding the need is becoming more and more important. Those standards that we see, the IEEE standards that define what PoE is, as well as other technologies such as digital electricity, which is delivering power, it's delivering the capability of performing work. So the average technician, the average low voltage installer these days, getting this education on what that means is very, very important.
This is why I love hanging out with people that are smarter than me. I've known the PoE wattages for years, 15, 30, 60, 90, and now 100 plus. I never paid attention to it before until you just rattled it off. Is it coincidental, or is there reasoning behind we doubled it? We went from 15 to 30, and then we went from 30 to 60. Is there a reason why we're doubling it, or is that just happen to be pure coincidence?
Well, we'll call it out of it was a product of coincidence because you happen to have so many pairs in a twisted pair cabling. When you really get into the standards of PoE and what it is, then you start to see that so many of the pairs, so 8 conductor, 4 pair cable, so many pairs are used for power on each standard. Right. These days, we're up to 4 pair PoE, which enables us to send a certain amount of power and data over each pair. Previous standards of PoE only used either 1, 2, or more pairs, depending on what it was and what the manufacturer was. But in a nutshell, that's kind of simplistically how you're able to multiply your power like that. But keep in mind that our industry standards these days that have done amazing things with power, with wattage, what the end-of-line voltage is, but also the data, the throughput of what the capabilities of signal transmission is, all simultaneously while delivering power. It's an amazing thing.
So you use the term that I've heard you use before, and I never thought about it till just now. What's the difference between end-of-line voltage and voltage?
Well, simply put like this. So we're going to go back to our analogy. We're talking about a pipe and water, and we'll talk about a spigot. Okay. The longer the hose, the more resistance. Okay. Therefore, the pressure that you get from the spigot or from the source is not going to be the same exact pressure that you get at the end of the hose. Now, Chuck, when you guys were installing your water features and trying to water your crops and whatnot, right then, before you started splitting it, before you started affecting the length of how far it had to travel, you probably had a decent amount of water pressure. But the farther you went, and the depending on the size of the hose you had, affected at the pressure at the end. Well, that's kind of what we see in communications cabling and electricity in general. All media has resistance and impedance built into it. That's just the nature of the impurities of the manufacturing process, whether it's copper or aluminum. And quite simply said, is that if you have a power source that's putting out 90 volts, AC or DC, by the time that voltage and that current gets down to the end of the cable to your product, you're not going to have 90 volts. You're going to have so much voltage drop. And that's due to the length of the cable, the resistance of the cable. And those are all things that even our technicians these days need to understand.
When we do lectures in class, we like to talk about, in terms of AC theory, purely inductive circuits and purely capacitive circuits, which is kind of beyond the scope of this, but they're purely theoretical. We always have to consider something called I squared R loss, and that's wattage loss, doing the pre-work to do the work we want as the end result.
Gotcha. So end of line voltage is basically your voltage drop between
Absolutely.
where it goes into the cable and where it comes out the cable.
Yep,
Yes, sir.
It takes money. It takes money to make money. It takes watts to spend watts.
I love that. Now let's tie it all together. This is probably why you were invited to be on the show, Brandon. Let's bring it all together. Talk about the relationship between volts, amps, and watts. And remember, we're talking to low voltage people here, not electricians.
Okay, so I'm going to assume that you guys are familiar with something called power factor, and when we go through doing calculations in my classroom on the board, I'll put an absolutely nightmarish 2.5 hour circuit on the board, and you're finding values for every single silly component there. And the only question I'm asking them to do is find the wattage for this nightmare. We'll spend 2.5 hours doing it, but at the end of the day, your volt amps apparent, that is the maximum allowable energy in your circuit at any point in time. And its unit is exactly that, volt amps. We don't know if they're reactive. We don't know if they're watts. But once we have that power factor, we just have a simple multiplication. We can compound our power factor with our VAs, and that tells you exactly how many watts you can expect.
Gotcha. So since you're the mathematician, there's always that diagram that talks about voltage and current and all that stuff. And if you have two values, you can calculate the third. Can you walk us through that?
That's about a 3-hour conversation.
So that'll be on part 2 and part 3 then.
So when you talk about AC or DC or rectified AC to get DC, you still have to you have some compounding problems called capacitance and inductance, and those are a lot of the calculations that you have to lot for when you're getting your eventual VAs and then finding your power factor and your phase angle using inverse trig. Simply put, it is a lot of math, and it's a lot of calculations on a whiteboard that it's that nightmare you got back there, and we'll save that for possibly a later time.
Right.
Yeah.
So
and all electricians and technicians these days need to kind of have the basic understanding of Ohm's law and that relation between voltage, current, and resistance. Simply put, it's a basic mathematical formula that affects all power transfer and electricity and wattage and power, and that's the whole concept of your resistance times your current equals your voltage. Okay, but once you understand Ohm's law, look it up, then the nightmare behind the board there will start to look a little less intimidating. But that's the importance of understanding all the theory, all the mathematics, because without that, then we cannot keep this industry moving in the right direction.
Right.
And it's important to realize that DC it's a function of AC theory. It's just AC with frequency 0. There's a standard set of laws that electricity is going to follow no matter what it's forced to. It has no choice. And depending on whether you're working with DC or AC, there's special cases in each.
Excellent. Great discussion there. Now let's talk about some common mistakes by low voltage people, not electricians, right? So, Brandon, what are some of the common mistakes that you see done by low voltage people when it comes to volts, amps, and watts?
So perhaps I didn't introduce myself correctly. I'm a journeyman wireman. I'm not privy to a lot of mistakes that the techs get to make. I'll let Matt answer that one.
What about you, Matt?
Well, when it comes to power, we've said the term AC and the term DC. Okay, AC is alternating current, DC is direct current. One of the major mistakes that I've seen is that people aren't understanding the difference, or they'll have a power supply. I'll go back to a commonly installed system that requires power supplies is access control and security. Okay, not all access control and security items require. Put it simply like this: not all power supplies operate off of it put out DC and AC power. Usually, it's either or. Okay, if you're the installer in the field and you see that there's some power supplies and you know that you need to hook up a maglock, a magnetic lock set for a door, you need to be able to look at the maglock and see what its operating voltage and current is, and if it's DC to DC, and then find the right power supply and hook up the right power supply to the right maglock. And I see common situations like that where people are installing a DC maglock on an AC power supply.
Right.
That is a common mistake that I see. And it's just simply, it's very, very different. It's very, very different in operating functions of each. But that same principle can be applied to many other aspects of our industry, and also voltage levels and current levels when it comes to power supplies and things of that nature. Is that power is just not power. Voltage is just not voltage. Since a lot of the things that are installed these days are very, very unforgiving, you will let the smoke out. So I see people put the wrong appliance on the wrong power supply, whether it be an under voltage or over voltage situation, and just simply blow things up, or they just put it on the wrong power supply.
Yeah, if it takes 50 volts DC, we can just use RMS AC. Nothing bad can happen.
And sometimes that piece of equipment that it burns out, not cheap.
No, and they're not cheap. A lot of things these days with solid state electronics, they are not cheap.
Yep. So what are some resources if somebody listening to the show and says, "Man, this sounds interesting"? What are some resources or places that a low voltage person can go if they don't happen to live in Las Vegas and go to your school? What are some resources for them to learn more about volts, amps, and watts?
So one of the good ones I've been digging in for resources for my students is a website called All About Circuits. Mm-hmm. And it can take anywhere from a grade school approach to explain things to all the way up to engineering. It's where I find a lot of my resources. It's pretty user-friendly. A lot of very good diagrams explaining anything from the basics to the engineering standpoint of where you get the square root of 3 for three-phase.
Matt, do you have any resources?
All About Circuits. You can even go to some of our manufacturers have pretty good explanations of power, and I'll use one manufacturer for instance, is Softing. On Softing's website, they have some videos about POE that go into some of the specifics on what actually it is and the differences between voltage and current. So, and that's just one of our training manufacturers that we deal with. There are others. Fluke is another one that as well that has some pretty good product information and details on there. So that explain what the powers are in a very, very basic way, because they want you to be able to use their products. So they're going to help you identify some of those different variables.
One thing I grabbed during COVID, because we had we had to have the ability of showing things online without having anybody in person. It's really difficult to do a real-time analysis of a circuit when you're at a distance. Was a website called Every Circuit, which I think mine was a one-time fee of $20. But you can build just about any circuit you can imagine with switches, inductors, capacitors, and it'll give you the real-time values of them. It'll construct the real-time overtime wave functions for voltages across components, and you can superimpose them. It's been a really big benefit for my students.
What a great conversation, gentlemen. Did you have something you wanted to add there, Matt?
Yeah. I was going to say too is that for somebody that is also looking for information on as relates to power in our industry, the FOA. Everybody thinks FOA. It's just obviously just fiber optics, but it's really, really not. They have linear light wave, but they also have Uncle Ted's. And Uncle Ted's talks about premise cabling and the standards and specifications for that. So in Uncle Ted's on the FOA, they actually have some pretty good explanations when it comes to those other forces that we deal with. So definitely, if you're somebody that wants to learn more about those things and how it affects communications and premise cabling, FOA is a good source also to research and dig into.
Fantastic show. This is why I like to hang out with guys smarter than me, because you teaching me stuff too, man. I like that. I appreciate you guys coming on the show today.
Thanks for having us.
Thank you, Chuck. Anytime.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.